to let me know in the comment section. Thanks for joining. So in this very quick life section, it's going to be a quick one. We'll be introducing some shortcut formulas in the topic or the branch of physics we call optics. Okay, we'll be learning some shortcut formulas. Okay, let's see what we have for today. The shortcut formulas we have for today under the topic called optics. All right, we'll be learning some shortcut formulas. If you are just joining the live, do it to indicate in the comment. Thanks for joining. So let's get started. I think I will need to use this. All right, basically, when you are asked to find, let's say, magnification, if you are just joining the live, do it to indicate. Thanks for joining. Okay, let's get started. First thing first, there is something we all know to be what do you call it? Mirror formula and lens formula. It's basically used to find what? Focal length. It can also be used to find object distance and image distance. Okay? Normally, we know that mirror formula. Okay? Mirror formula and lens formula or lens formula. We know that they are both similar. Okay? What is the usual formula for mirror or lens equation? We say it's 1 over f equals 1 over u plus 1 over v. This is the usual mirror or lens formula, okay? As we already know it to be. So basically, in case you are finding it difficult to use this very formula, perhaps you are finding difficult, there are some shortcut formulas that we do better than this. Perhaps you don't really know how to work out this place. You are looking for early sim, or you are trying to, what I call it, work this out and let's say make V subject. It's kind of a little bit complex if you don't really know the mathematics behind it. So in place of this, here's the shortcut formula. Okay, the shortcut formula is just simply say that F is equals to UV over, this marker is not working very well, so I will need to refill it quickly. Sorry I didn't do this before we started the live, just bear with me. If you are just joining, let me know in the comment section. I'm glad to have you on this very space. Do it to stay to the very end, okay? It's going to be an interesting session, a quick one also. It's going to be quick, we won't waste time. It's already past 3. Alright, so let's continue. Instead of using this one, you can simply use F equals U times, this dot means times V over U plus V. This one would work. It's still the same thing. So if I'm looking for V, I'll just times this by this, then collect the ones with V to one side. I've gotten my answer. It's in case you don't really know how to work the LCM behind this. Alright? So this is the shortcut formula, the first one. I'll be kind of highlighting them. So you can write them out. And take note of them. Alright? So if you were asked to find, let's say, the image distance, you can simply use this formula and just make your V subject, you will get your answer. Now, like we know, magnification has a number of formula. We are basically revising optics formula and take note of the shortcut formula that goes with each of them. So to find magnification, what formula do we originally know as the formula for magnification? If you are just joining the live, let me know in the comment section. I'm glad to have you guys here. Okay, the normal formula we have for magnification is that M, magnification, is equals to height of image over height of object. This is for what? For pinhole camera. So if you hear, if the question carry this word, pinhole camera, okay, an object is placed in front of a pinhole camera. This is the formula you use. If you are asked to find, let's say, magnification, or you are asked to find the height of the image, or you are asked to find the height of the object, this is the formula that you should use. I hope that is clear. Alright? Let me just add where HI is what? Image height. Okay? Or height of image. I'm just trying to make everything short. And then let's say HO is object height. Object height. I hope we are taking note of this formula. Once you know all this, basically you shouldn't be stressing yourself with optics if you are just noting all this formula I am giving. Alright? So what else? Apart from this formula for magnification, there's another formula we can use. And this one mostly applies to mirrors and lens. Okay? Yeah. The formula is M equals V over U. So I will add for mirror and lens. So if you see in the question, an object is placed in front of a concave mirror, that is the formula you should use if you are asked to find magnification. Okay? It's kind of getting dark here. Let me just adjust things to, allow light rays to come in directly. Sorry we start late today. For those of you who have been following up, sorry we started late. So this is the formula you use for what? Finding magnification. In this case, V is image distance. Image distance. And then U is object distance. Object distance. Object distance. So take note of that formula. Very, very important for magnification. Now, if you check, the formulas for magnification are already too easy. Very, very simple. They are just fractions. This divided by this. This divided by this. So that one alone is okay. Now, sometimes, ensure you are following. Sometimes you might not be asked to find magnification and then you'll be given this and this, or giving this and this. What if they not give you focal length? They not tell that the focal length of the mirror or of the concave lens is this. Calculate the magnification. If you check, there is no F in this formula. There is no F which stands for focal length. Is it not? Let me add it here. Okay, F equals, okay, let me circle this. Mind you, this is not my shortcut formula. This is one I introduced. Okay, where F is focal length. In case this is your first time just trying to go through optics, just know that F is the focal length I am talking about. Let me check in case anybody have any question so that I won't leave anybody out. Good, we are falling. I'm glad to have you guys on this space, and I hope we are getting what I'm saying. Now, the question before us is, this is HI over HO. This is V over U. What if we were given focal length and we asked to find magnification? Guys, which formula are we going to use? Now, here's the formula. It will depend. It will depend. So I'm introducing two formulas, so I will indicate shortcut formula. Shortcut formula. This will save you a whole lot. This will save you a whole lot, guys. I promise you. Stay tuned to the end. It will save you a whole lot. Now, if you were given focal length and object distance, F and U, and you are asked to find magnification, here's the formula to make use of. M equals to F over U minus F. Once you know this formula, there is nothing in this world that can make you fail this question. You don't even need to know the rest in it. As you just check, okay, this is my value for focal length, this is my value for object distance. Focal length, they say the focal length of a concave lens. Because if it's concave, there's something that you should note about the focal length. It will always be what? Negative. If it's convex lens, it will always be what? Positive. I will add it to it. Just stay tuned to the very end. So just take into the two values, you have already gotten your answer. Somebody is reading to the end, but you have already gotten your answer. So this is the first shortcut formula. I hope this helps. I hope this helps. Anybody's got any question in the comment section? Now, what if you are given focal length and image distance? What is the formula to use? It is M equals V minus F over F. Guys, be taking note of what we are doing. This is the formula to use. Just note the value for the V, that is the image distance, as we already said, and the value for the F, focal length. You will surely get the right value for your magnification. I hope that is clear. Take note of all this. Now, if perhaps you were asked, okay, this will do, this will do. Now let's think of something else. I said something before we continue. Before we continue, I said something. I was making mention of concave and convex. Concave and convex. You heard this in my mouth, is it not? So I think we have to look for a way to introduce it here. For concave mirror. For concave mirror. For concave mirror. So in case they said the focal length of a concave mirror is, let's say, 10 cm. Just know that it's not just 10, but it is positive 10. So that what I'm trying to indicate here. For concave mirror, F is always positive. Emphasis on positive. Take note. So if they say the focal length of a concave mirror is 10, guys, what does that translate to mean? It means that the focal length of that mirror is plus 10. So in this formula, you should use what? Plus 10 and not just 10. I hope that is clear. I hope that is clear to us. Alright? We are doing great. We are doing great. Let's move on. Now for concave lens. No, okay. Before we go to lens, let's finish with the mirror. Alright guys, take note of something. This guy, I need to kind of put this in somewhere. I don't want to jump pack everything. I hope we are taking note of what's on this side. We have taken note of it, right? Let me just write everything here. Take note, you can take your screenshot. You can always get the video when we are done. It will be saved to the channel. So let's just write it on this part of the board. Let's just write it on this part of the board. Alright? Let's see what we have. And I can actually do this in, let's say, as a table, better still. We can actually do this as a table. It will just save time because the aim of everything is to get shortcuts, okay? Instead of just sticking to the traditional formulas you already know. Now, if you can actually put all these things together in your head, trust me, you are good to go. So let's use something like this. Let me use something like this. Alright? Focal length. Is this good to go? Okay, let me increase here. Sorry for the slight changes in everything. I just want to make it better for us. So let's see. For concave mirror, focal length is always what? Positive. First thing first. So we can write here mirror. Let's just say mirror. Okay? Now this concave mirror is also called diverging. Okay, let me think. It's also called converging mirror. Sorry, I'm trying to bring everything from my head. Converging mirror. Okay? Convex lens is called converging lens. So concave mirror is called converging mirror. Okay? So if they say an object is placed in front of a converging mirror, you just know that the focal length is always what? Positive. So we rule this. Now for convex mirror, it has another name. In case you did not write convex mirror, it's also called diverging mirror. Note that the focal length is always negative. I hope that is clear. Are we following up to this extent? Are we following up to this very extent? Alright, let's go to lens. So this is for mirror. All this is for mirror. We kind of circle it out. Now let's go to lens. For lens, okay, we'll do the same thing. Just draw, then you draw. Alright, let's make this straighter than this. Alright, for lens, let's see what will happen. For lens, we are looking for what the focal length will be like. Okay, now for lens, for concave lens, which is also called diverging. So observe the difference. There was an intertwist. There was a twist here, watch out. Concave mirror is also called converging mirror, while concave lens is called diverging lens. So you need to master it with ease. So that when they are saying an object is placed in front of a diverging lens, you should not say it's a convex lens, but rather you say it's a what? A concave lens. So concave mirror or converging mirror, concave lens or what? Diverging lens. Take note of that. Now for this, the focal length is always negative. Observe the difference too. Are we good? Good. It's just like they are just twisting it. For this very two table, they just, okay, we said concave lens, concave mirror, yeah. We said concave mirror is converging mirror. So in this place, we are saying concave lens is diverging lens. Just get it, it's just twisting everything. Now for what? Convex lens, also called converging lens. Let's see what we have, guys. Okay, focal length is always positive. So I hope the twist is very clear. So I can only, sometimes it is just for me to just cram this first table. I know that for lens, everything is just the inter twist. Is it not? Factual. So just take note of this table also, guys. Very, very easy. Take note of the table. I hope we get this. I hope we get this. Did we get that? Let me know in the comment. Sorry for the dim light. We just have to just manage it. It's already towards evening, okay? Let's just manage it the way it is. Yeah. All right, let's progress. Now, what is the essence of these two tables? Let me tell you, so you don't just have it and you don't know what it is for. So if they said an object is placed in front of a converging mirror, I will find it, I'll trace it, converging mirror. This is the one they are talking about, right? Then I said, whose focal length is 10? I will know it's not just 10, but it's what? Plus 10. So I will put it here. Then I said, if the object distance is this, find the magnification. Let's say if the object distance is 15, find the magnification. This is what will now happen. Plus 10 over 15 minus, because the focal length will still be the focal length here, it must always carry that plus 10, showing that it is what? Converging mirror. So I'll still put plus 10 under. Are you seeing it? Plus 10, plus 10. So I'm finding magnification now. Watch out. Plus 10 over minus times plus is minus. So we have 15 minus 10. Minus times 10, minus times plus is minus. So that's why we have this. So this will now be plus 10 over 15 minus this is what? 5. Divide, you have what? Plus 2. So guys, what is the magnification? Plus 2. Or you simply say 2. That is the answer. So imagine I'm very good. I've already mastered this thing. I can just do the math in my head. And be like, wow, that's crazy. You got the answer. It's just for you to know this shortcut formula. I hope this is clear to us. I hope this is clear to us. Is that clear? Let me know if it's clear to you. So guys, this is this. This is what we have. This is for what they call it. Yeah, basically for lens, mirrors, and then for magnification. Let me check. I think there should be something for, let's just add refractive index. Refractive index. So we do that on this side of the board. Okay? We will do that on this side of the board. But before we even do that, even if we only end up talking about mirror and lens, it's already something. Okay? We can just say, let's just take one or two extra things, then we take questions under this. It's okay. We can actually leave refractive index and the rest for another day, because I don't want the board to get blurred than this. It will be nice teaching and you are not seeing it. So let's see what we can add in addition. But basically, I hope this is clear. I hope it's clear to us. Let me know if you are just joining. Thanks for joining. And also, if you are new to the channel, I would like if you actually subscribe. It will go a long way. Okay, so that you will not just be a one-time viewer, but a full-time member. It's something like it shows you are really following. Okay, you can also drop a comment. Let me just know you are around. All right, let's continue. One more thing I want to add under this mirror and lens stuff. Be taking note of the formulas. Is that there is, okay, let's draw something for the mirrors. God help me. Converging mirror. This is how a converging mirror is. That's basically how they are. Now for converging mirror, this is where this part is not the part they used to see. Is the side that is, let's say, polished. Not polished, that's not the word. Painted. This is the painted side. This is the part that is reflecting. Or this is the part that I used to see. Okay? So you hold the mirror like this. You hold the mirror like this. This is how you can see it. This side you cannot see it. Polished, painted. Follow me. Okay? Now, if an object, okay, there's something they call, this is called the vertex. The vertex. Okay? This is called the principal axis. I'm just trying to remember things offhand. So just stick with me. Just stick with me. Is it remember things offhand or remember things by heart? You learn by heart, but you remember things offhand. So I was right.
So let's see something here. Now this is for a concave mirror. For a concave mirror, okay? Now, this place has a value. It is called F. F, like we know, is what? Focal length. This place is the center of the sphere from which this mirror was cut off or cut out from. Okay? Now this is the concave mirror. And this place is 2F. But because of some stuff, it is called the radius. Okay? Yeah. Let's just leave it like that. It's usually given as C, center of the mirror. Center of the mirror. Now take note. From year to year is called arrow. So guys, what is arrow? That's what we should be asking ourselves. Arrow is equals to radius of curvature. Radius of curvature. Now why am I adding this thing? It's for some reason. Sometimes, somehow, you might not be given the what? Focal length. So I'm trying to clarify things so I won't leave any stone unturned. What if they said an object stand in front of a concave mirror whose radius of curvature is 14 cm? If the object distance is 5 cm, calculate the magnification. You'll be like, but the formula that they gave me, the one I just finished teaching you, there was no one that actually have arrow. Oh God, I am stopped. Now, if you are given radius of curvature, you can actually get your focal length. Here's the formula to use. Focal length is always equals to radius of curvature over 2. Okay, let me be specific. I was taught physics. Radius of curvature is not in capital letter, it's in small letter. Always in small letter. So, small arrow over 2. Take note of this formula. So, if you were given your radius of curvature, you can get your focal length, and from your focal length, you can get your what? Magnification. It's just step by step. Don't just conclude I can't solve it. It's step by step. One step leads to another step. I hope we get this formula, guys. I hope we get the formula. Okay? So that is for it. If you were not given focal length directly, if you were given what they call it, your radius of curvature, whether for a concave mirror or for a convex mirror, so there's really no need for me to add this. You understand me? Whether you are giving it for your concave mirror or convex mirror, if you are giving the radius of curvature, first thing first, get your focal length. Then you can now find either your own object distance or your image distance or even your magnification, depending on the one they are asking you to find. So don't conclude I can't solve it. This is the formula for converting radius of curvature to your focal length. I hope that is clear. Okay, let's just conclude the whole thing. Let's conclude the whole thing. Yeah, basically what I can remember right now. When I'm done organizing it as a series, I'm still working on the entire notes on this. Shortcut in optics. Basically, I just want to just drop these ones. So let's see something else. Take notes. Note. Okay? I'm concluding now. That for convex mirror, okay? Take note that the image form is VED. I will explain. Each of them stand for something. I hope we are still following. Thanks for joining the live. I'm glad to have you guys on this live section. Now, when I say image form is VED, each of them stand for something. So, in case you ask some kind of question, you're not going to miss it. V, E, and D. Image form 1. Image form is virtual. 2. Image form is always erect. 3. Image form is diminished. Take note of these things, guys. Take note of these things. Don't let them to make you face simple questions. So if you were asked which of the following is not true of the image formed by a convex mirror, which of the following is not true of the image formed by a convex mirror, you should know that if any of this is in the option, they are correct. But there will always be one, how do I call it, black goat that is there. that will be the correct answer. Like the one that will be off point, that will not, you will not take as your answer. Is it not? Image formed by a convex mirror is virtual. True. Image formed by a convex mirror is always erect. True. Image formed by a convex mirror is diminished, not magnified. Virtual, not real. When I mean real, R-O-E-A-L. It is virtual, not real. It is erect, not inverted. Take note of this. They will not be twisting it. Is it virtual or real? Is it erect or inverted? Is it diminished or magnified? Just know that if you see any of these, they are the one that you pick, because image formed by a convex mirror is VED. I hope that is clear. I guess we're enjoying the class. Alright, let's progress. I want to clean this up so that in case you are going through it, you won't be confused how they came about. So there is something I want to also add. Kind of a quick one. Let me think. Alright, let's add this. So I can clean this part, right? Let's just make do with this part of the board. Let's make do with this part of the board. So we are going for that. We are progressing. We are making good progress. Let's see what we have to say here on this part of the board. On this part of the board. So like I said, if you have any question, let me know in the comments. Don't just watch. If you are confused, let me know. You not commenting is a sign or a feedback to me that you're understanding, and I hope that is true. If you don't understand anything, let me know in the comment section. If there's a point you are confused, indicate in the comment section. I will treat it again. Okay? So let me check. If you have gotten any question for me, let me know. Face Tunis, hi too. How are you doing? Trust you're having a great evening. So now take note, for a concave lens, imaged form is always VED. So check, it's the same thing. Are you seeing that? Concave mirror, what am I saying? Convex mirror, concave lens, they form the same type of image. They have the same image characteristics. Observe that. They have the same image characteristics. Okay? This one for concave mirror, convex mirror, is VED. This is the image characteristics. For a concave lens, it's also VED. Take note. So it means that if I'm looking at a concave lens, the image that we show will be smaller than the size of me, myself. If I'm using because this convex mirror is one I used to make, what they call that, there's a name, that is how they put it in physics textbook. This shaving mirror, let me just call it shaving mirror. The one that men use when they are shaving, let's say their beards and all that. So what happens with a convex mirror is that it will make the image smaller so that you can get a clearer picture of all parts of the face. If it's bigger, you will only be seeing small part of the beard, is it not? But it will make the image smaller so you can see a fuller part of the face and be monitoring your shaving. I hope that is clear. So it is convex mirror that is used to make shaving mirror. Take note of that. I guess we are following. Okay, so that is for that. So basically, I just want to conclude the live. I'm kind of watching the brightness of the live, so I don't want to go beyond evening so that our image will be blurred. So we will conclude with a question. Fine, we've already discussed all the theories, we've already discussed all the shortcuts. Let's practicalize it with one question. So let me get a question, guys. Let me get a question. Perhaps I can get one from this list. I supposedly should get one. So just stay with me. Let's get a question and see how the magic will work. Let's see how the magic is gonna work. Ta-da-da, ta-da-da. Let's see how the magic is gonna work. Looking through. Just bear with me, please, guys. Bear with me. Sorry, I didn't plan it out. I just came back and I'm like, okay, I have to shoot today. Let me see what we can pick our answer on. Let's see. Alright, I've seen a question. But this one won't be straightforward. I need something that will be very much straightforward, guys.
You can go ahead and solve your own question later in the evening with all this formula and explanation. Okay, the ones you don't understand, just drop it in the comments of this video later on. Okay, it's still the same thing. I will get back to you. Okay, it's just basically going to be the same thing. Alright, basically I will stick with this question since that is the case. I will need that thing. I will need it, please. I will just stick with this question because I don't want to waste our time. Question, 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 question. This is the question, guys. It's kind of long, but we have to copy it. They said a dentist, like I said, just bear with me, I'm writing the question. A dentist obtained a linear magnification, okay, of 4 by placing a concave mirror. So we have seen a key point. Something has struck our mind when we heard concave mirror. Our body have been what? Sensitized already. You should be thinking of something now. Okay? At a distance, okay, by placing a concave mirror at a distance of 2 cm from a patient's tooth. Forget about the drama that's being explained. Just focus on the values and what you're asked to find. From a patient's tooth. Okay? We're told that it placed the mirror 2 cm from the patient's tooth. What is the question? Calculate the focal length. Focal length of the concave mirror. Now, look at this. Very interesting. Very, very interesting. Okay? All right. I suppose we are on point. It's like we made, wait. Concave. Okay, yeah. We are on point. All right, let's progress. Now, this is the question. We are asked to find focal length. So, like I always do when I'm giving physics question, first thing first, the right order was given in the question. Thanks for joining live. Thanks for staying to this very extent. Okay, let's continue. Solution. You know we have to make use of this other part of the board, basically. So let me just do the cleaning before then. Wipe this off. Let's see what we have about the question. The question reads, we go over the question again, guys. A dentist obtained a linear magnification of 4. So we're giving magnification in this question, is it not? Forget about the term linear. Though there's something like linear magnification and angular magnification. But stick to the fact that it's n we're giving, right? N was given to be 4, is it not? A linear magnification of 4 by placing a concave mirror, I will underline because this is very important to me, at a distance of 2 cm from a patient's tooth. So we're giving object distance. Why did I call it object distance? The mirror was used to view the teeth. So you take the teeth as the object in front of the mirror. Clear? It's the same thing as saying a boy stands in front of a mirror. The boy will be the object. So the mirror is placed in front of the teeth, 2 cm from the teeth. So the teeth will be the object. So the distance will be the what? Object distance. U was given to be what? What's the distance? 2 cm. Very, very easy. No stress. From the patient's tooth, and we are asked to find the what? Focal length of the concave mirror. Focal length, as we always know, is always what? Okay, wait, we don't know the value here, Abi. So we'll leave it as question mark. Now, guys, kind of screw backward. Check. When I gave magnification formulas on this part of the board, the one that involve focal length, pick it. Which of them are we going to use? Is there wrong with that view? So what was the formula I wrote there? I said magnification is equals to
focal length over u minus f. True or true? True. Is it not? So we are on point. We have n. We have u. We are looking for f. So let's see how the magic will work. Let's cook. Let's cook. So from here, we will now say, in place of n, put what? 4 equals to, in place of f, we don't have a value for f yet, so we leave it as what? F. Just leave it like that first. Over, in place of u, put 2. We are cooking. Minus in, okay, f, we don't have a value yet, so we leave it as f. So God help us. God help us. What do we have to do? We are looking for f. This is a fraction. We can cross multiply. Is it not? Cross multiply. Imaginary one we times this. That will be f. Is it not? 1 times f will give us f. 4 times this guy. It will be 4 in front of 2 minus f. Observe how I did my multiplication. Observe how I did my multiplication. I hope we are getting it. Observe how I did the multiplication. So this is what will now happen from here. This is what will now happen from here. We are asked to find focal length. So this side of the equation, I want to expand it. How will it look like? It will be f equals to 4 times 2 is 8. We know, right? 4 times 2 is 8. Minus, because of this minus, 4 times f will be 4f. 4f. Are we still together? Yes, we are. So now watch out. What do? We are looking for f. So all the ones with f, we will carry it to one side of the equation. So minus 4f will cross and jump this equality sign. It will land here. Are you seeing that? It will now be f minus will change to plus 4f. It has jumped successfully. It will be equals to what is left? 8. That is it. F plus 4f. There is an imaginary one here. So 1 plus 4. It will be 4f. 1f plus 4f. 5f. Sorry. I made a mistake. Is what? 5f equals what? 8. Are we still together? So let's progress. Now we are looking for f, not 5f. So we'll divide both sides by whatever is in front of f, which is 5. 5 cancel 5. F will now be equals to what? F will now be equals to what? You can do it with your calculator. 8 divided by 5. 8 divided by 5. That will give you 1.6. Guys, is that correct? That will give you 1.6. 1.6. Alright? So that is the answer. That is the answer. 8 divided by 5 give us 1.6. You can confirm it. Let me just confirm. Okay? So I won't be making errors. 8 divided by 5. 1.6 centimeter, because focal length is a length too. So it will have the units we are using, cm. Guys, check something. This is our answer, but do you know we can actually proofread our answer? There's a way we can check that our answer is correct. Let me show you. Let me show you. Is there a minus sign in front of our answer? Like, do we get minus 1.6? There is no minus sign, Abi. So it means that our focal length is positive. And mind you, it is a what? Concave mirror. So go back to that table I gave for mirror. Under concave mirror, did we say that for concave mirror, the focal length must be positive? Was that what we wrote? Yes. So because this value, positive 1.6, agree with that table, we already know that we are what? Correct. We don't need any other further check. This is our answer. Is that easy? It's not difficult. So guys, I hope you understand the mathematics. I hope you understand the magic. Very, very simple and sweet. Shall we get it right? So this is for it. Try more questions under it. When you get back home, just take your past question or your textbook. Try more questions on optics, mirror and lens. And trust me, it's going to be a smooth ride. Thanks for watching to this very extent. I hope you enjoyed the live session. If you are new, don't forget to drop a subscribe so that you'll be a member of the channel. Thanks for joining and thanks for staying to this very extent. I will see you guys in the next live section. Peace out.